They decompose state relevant data from the data booklet and use it to predict the order of the thermal stability. So what happens? Greater charge density, that means it's more unstable. Okay. The logic behind this is you have smaller ions. Okay, just hold on 1 second. So you've got smaller ions. So it's going to have greater polarizing, greater charge density. Or just because of which, I mean, that's the explanation for group 2 carbonates, a greater charge density. So carbonate ion is more polarized, or there's more polarized and more unstable. So that's the explanation. So what data are you going to pick up from the data booklet? You're going to look for the size of the ion, lead ion, calcium ion, and zinc ion. Okay. The carbonate is the same in all 3 cases. So open the data booklet and find the size of the ions. The smaller the ion, the more unstable it's going to be. Okay, so somewhere in the data booklet, over here, I think. So now over here in this data booklet, you have the ionic radius. So you had, you had lead, and you had. So where is lead? Anyways, transition metals. Just a second. Okay. I said zinc is over here. It's 0.135. Okay, so you've got zinc, and you've got.
तो उसका ionic लेंगे या atomic?
Ionic, sorry. Ionic, sorry. Okay, so you're going to take the ionic radius, which is 0.075. So where is, I mean, lead must be somewhere over here. I said that's lead, that's +2, 0.120. And you've got calcium, which is going to be in group 2. So calcium is over here. So who's the most unstable? The smaller the ion, that's the one that's going to be the most unstable. So in this case, it's probably going to be, I'd say it's probably going to be which one? It's probably going to be calcium. That's the one. It's going to be zinc. That's the one that's going to be the most unstable. Okay, is that clear?
Yes, sir.
Yes, sir.
So, but you just have to explain that. So what's the next question?
AC का D part.
So D part is dolomite contains a double carbonate of calcium and magnesium, and some impurities. 1.642 grams of dolomite reacts with an excess of hydrochloric acid. So this is what the equation or reaction is going to be. Okay, so you've got calcium and magnesium carbonate. Probably what this is, it's basically a combination of calcium carbonate and magnesium carbonate. So if it reacts with what HCl, so what is the reaction? It would form calcium chloride, and it will also form magnesium chloride, and plus water plus carbon dioxide. You just have to balance this. So I guess you need 4 HCls. And there's going to be 2 H2Os, and there's going to be 2 carbon dioxides that are produced. So that's your balance equation. So what is given? It's given that 125 cm³ of carbon dioxide is being produced under room conditions. So how many moles is that? 125 divided by 24,000. So क्या आ रहा है? What?
5.21 into 10. 5.2121.
अच्छा, into
10 -3.
ठीक है, ये moles आ गए. ठीक है, those are your moles. So the moles of this thing would be half of that. So it's going to be 5.21. So 5.21 into 10 raised to the power -3 divided by divided by 2 moles. And once you have moles, you can find the MR, you can find the mass. So multiply it by the MR of this, and you will get the mass. Up here, you just have to find the percentage in the 0.642 grams. So if you multiply it by the MR, what do you get for that? I mean, this is, I think, 12 into 330.
Sir,
12 into
given mass over
360.
calculated mass निकालेंगे या calculated over given?
Calculate the percentage. Calculated over given, no? Pure versus
Calculated
impure.
over given.
I mean, it's pure divided by the impure into 100. वो खुद ही understood है कि दूसरा तरीका करोगे तो that will give you greater than 100%. So that is obviously wrong.
Okay, sir.
ठीक है. और कौन सा question है?
एक सेकंड सर मैं इसको कैलकुलेट कर रही हूँ.
Well, 120 plus 40, 160.1 plus 24.3. कितना है? अच्छा मेरा 0.480 grams divided by the total, which is 0.642 grams. ठीक है, सही है?
It's around 75%, I think.
हाँ,
जी,
मतलब वो
sir.
कर लो. अच्छा, next question.
So question 3 का D part के इसके ना how do you figure out coordinate number?
नहीं, वो तो easy है. This one is easy because they've given you information about they've told you the coordination number. That means that's the number of dated bonds that it's going to form. So that means there would be 4 CO. There's going to be 1 nickel, and there's going to be 4 COs in the complex. ठीक है? Is that clear? Okay, what does 4 mean? ठीक है? And what would be the overall charge?
Yes.
Nickel is +2 and CO is neutral, so the total charge would be +2. ठीक है? So the total charge on this thing. अच्छा, ये तो +2 है. अब इधर आ जाओ, the next one, you've got Fe3 plus and Cn minus 1. So the total charge on the complex is -3. So how many Cns do you need for -3?
6.
3.
Need 6.
6.
Because you've got +3 and this is -1. So this has to be multiplied by 6 so that you can have, so there would be 6 CN9s. So the coordination number would be 6 because there would be 6 CN9s surrounding the Fe. So the formula would be CN6 and the total charge would be -3 on the complex, which they've already given. Clear?
So why is it 6 coordination number?
No, because the total charge on the complex is what? -3, right?
Mm-hmm.
So एक ion है which is +3, the other one is -1. So you know the metal line to complex में there's only one of them, right?
Yes,
So
sir.
there's an Fe3 plus, right? And it's being surrounded by Cn -1. तो खुद ही हिसाब लगाओ कि how many Cn -1s do you need around the Fe3 plus that the total charge becomes -3. 6 चाहिए होंगे ना? There's
So
going to
sir.
be.
Yes, sir. Yes, sir.
But remember, ligands, their quantity could be greater than 1. I mean, the metal line is always 1. Okay, so you're not going to increase this number. चलिए और कौन सा?
So इसी का F part. The F part 2 इसका explanation.
ये वाला?
Yeah.
Acha, suggest an explanation for this difference by the reference to both equilibria. So standard entropy change delta is for equilibrium 4. This one is plus 23 kilojoules, and for equilibrium 5 is minus 84. Acha, in one case, the entropy is what is happening to the entropy? It's increasing. Okay, there's more disorder, right? Plus means more disorder. So if is wale mein, you've got more disorder. So so the question is, why do you have more disorder? The reason you have more disorder is if pehle you had how many particles? You had 2 particles, right? So you had 2 particles. You had an EN molecule and you had a complex. And after the reaction, how many particles do you have? You have 3 particles.
3.
Okay, 3 particles, 3 ions or molecules. So that means there's an increase in disorders. So that's why it's plus. Okay, is that clear?
Yes.
What's
the next part, the explanation.
The second one, equilibrium 5.
Yeah, equilibrium 5 kyun kam hai?
In this case, equilibrium 5, you have 3 particles here and you have 3 particles over here. So I think the question was more about the relative comparison. Why is the disorder increasing over there? Minus 8.4 is like, it's almost 0. It's or close to 0. So over here, you can write that the disorder almost remains the same because you have 3 particles initially, 1 of this and 2 of that. And over here, you have 1 molecule this and 2 of these. So the disorder kind of almost remains the same. So I think it was a question about relative comparison. Okay, in the first one, the disorder is increasing, while the second one, or the first one has a greater increase in disorder compared to the second one. Okay, is that clear?
Yes.
Just remember, just remember when you're talking about qualitatively, like if somebody tells you that there is a reaction, H2 gas reacts with Cl2 gas and produces 2 molecules of HCl gas. Now, in this reaction, qualitatively, by just guessing, you can't really predict whether delta S is positive or negative. What you can guess is, okay, there's going to be very little change in delta S because there are 2 particles over here and there are 2 particles on the other side. So in this case, you can't really clearly tell whether delta S is going to be positive or delta S is going to be negative. What you can tell is that the delta S is going to be really, really small. Okay, it's almost the same disorder and almost the same disorder in the product as well because 2 molecules on both sides. So yeah, when you're talking about qualitatively, or qualitatively means you're just guessing whether the disorder is increasing or decreasing. In that case, if it's really obvious, then you can tell for sure. In each case, it was pretty obvious that disorder would increase. In this case, you know that the disorder or change in disorder would be very, very less. Whatever it is, you can't really guess. Okay, is that clear?
Okay.
अच्छा और कौन सा?
इसका third part ये वाला.
So of the 3 copper complexes, 4 and 5, state the formula of the copper complex that is more stable and explain your choice. The greater value of K stability, so it's this one. Okay. Greater value of K stability means that there's going to be more forward reaction, which means that this thing will be formed in greater quantity, and which indirectly means that it's more stable. That's why it's getting formed.
So why is number 4 more stable?
Because K stability की values are there. What is K stability? K stability is the Kc of this equilibrium, right? Product concentration divided by. So when you have a higher value of K stability, what does that mean? It means there's going to be more products, right? So यहाँ पे there's going to be more products. If there's going to be more products, that means this is stable. That means, I mean, the reaction wants to form this. Okay. And this one is unstable. It doesn't want to form this. Okay, is that clear?
Sir, thank you. Yes, sir.
Sir, इसका question 4 का B2 मैं पूछ रहा था कि the rate constant never changes, right?
Except with temperature. I mean, rate constant is similar to equilibrium constant. They only change with temperature, and they increase with temperature.
Okay, so they will decrease this case. इस वगैरह table में
it will
छोटा सा table.
क्योंकि remember कि when you say rate depends on there's a constant, it depends on the reactant concentration, right?
Yeah.
I mean that's your rate equation और कोई order होगा, ठीक है? So what happens is कि if you're decreasing temperature, you know the rate slows down, ठीक है? The concentration is not changing. You're not changing the concentration, but you know that when you decrease temperature, the rate of the
It'll slow
reaction.
down.
तो फिर उसका क्या मतलब है? K is basically decreasing, right? क्योंकि the reactant
तो दोनों का
concentration.
decreasing होगा.
The first rate of reaction will obviously decrease.
And rate constant will decrease as well.
Will decrease as well.
Okay.
और कौन सा?
Ask a D part. How to make that graph?
So on the axis below, sketch a graph to show how the initial rate changes with different initial concentrations of CH3, CH3 in this reaction. So initial rate now. So what is the order with respect to this thing? It's
1.
It's 1, right? So that means
Yeah.
the relationship that you're plotting is rate is proportional to CH3 COCH3 concentration and the order is 1. Okay, it's a direct proportionality, right? So what kind of graph do you get for a directly
Straight line.
Increasing.
It's going to be a straight line. Okay, that's what it would look like.
There were
तो order two
straight
का ज़्यादा
line,
start होता
wasn't
है
it?
ना?
You catches?
Wasn't a straight line for order 0.
No, you're mixing up two graphs. Okay, this is not that graph. Okay, that graph was something. एक से मैं खोल लूं. I said, उस graph के ना, that graph had different axes. It was something totally different. Just a second. Oh, just one second. Let's pick खोल लूं. I said that graph was concentration with respect to time. Okay, how does the concentration vary with respect to time? So in this graph, अच्छा ये थे वो graph, order 1, order 0. So in this graph, what happened was that the concentration of the reactant would decrease and it was a concentration time graph. Okay, clear है? The axes are totally different.
सही है. तो इसके अंदर rate versus concentration के अंदर it's either going to be steeper.
हाँ वो तो you just have to, मतलब they can give you any graph. ठीक है, just look at the axis and just make sense out of it. ठीक है, so
and order 0 का like straight to होगा
नहीं हाँ
constant.
मतलब वो मैं बता देता हूँ एक सेकंड. किधर है? हाँ, if this was order 0, the rate will not change if the concentration changes, so it's going to be a straight line. So this is order 1.
सही.
ठीक है, order 0 would be a straight line because the rate will remain unaffected if you keep changing the concentration.
And order 2 will be steeper.
Exponential, क्योंकि order 2 होगी ना, that's y is equal to x squared. ठीक है, तो मतलब what is y is equal to x squared? That's, so as the concentration increases, it goes exponentially upwards, right? ठीक है.
Okay.
ये 3 ग्राफ्स पर के अलग से लिख लो.
हाँ लिख लिया.
See the next one.
So question 5 का C part.
So you've got this enthalpy change are given, the standard delta HF. So K, determine the standard enthalpy change of solution of potassium sulfate. So first thing, I'm going to write the equation. What is enthalpy change of solution? That's K3PO4, solid. It mixes in water and it dissolves. And when it dissolves, it's an ionic compound. So it's going to dissociate. So it's going to produce 3 K plus 1 aqueous ions, and it's going to produce 1 PO4 minus 3 aqueous ions. Okay. I said this is what we are looking for, enthalpy of solution. This is what we want to know. So we're going to try and create this other path. You can see what is this other path. So if I want to create this other path, the information that I have is I'm going to connect the first equation. But then if I even need to connect the first equation, but I'll connect the first equation, which is enthalpy of formation of K3PO4. Pure, is there any other data given? I don't think so. So that's the only information that's provided. So enthalpy of formation, I've got K3PO4. So I'm going to form enthalpy of formation is 1 mole of K3PO4 is formed from its elements. What are the elements? There are 3 potassiums. What is the other element? There's a phosphorus, which is also a solid. And there are 2 oxygen gas molecules, right? And the value for this is minus 2035. Okay. So that's I've connected the first reaction. Next one is they're saying that P reacts with O2 and gains 3 electrons to form PO4 minus 3. So I'm going to do that. So over here I have that this can be produced. I'm not going to do anything with the K plus 1 ions, aqueous. They're not taking part in this reaction. Everything is revolving around PO4 minus 3. So what is happening? P solid. And it's reacting with 2 O2 gas. And it's gaining 3 electrons, right? So the K plus 1 doesn't do anything in this part. It's just P plus O2 plus 3 electrons. It's forming PO4 minus 3, and that's minus 12. 84. ये clear है? ठीक है?
तो P को PO4 minus 3 में कन्वर्ट करेंगे.
किसको?
P इस part के अंदर. Second part के अंदर.
नहीं ये जो है, this is what I've done ना कि I took P and O2. वो कहाँ से है मुझे नहीं पता, ठीक है? I knew कि PO4 minus 3 can be formed. I had PO4 minus 3. And I knew it can be formed from P solid plus 2 O2 plus 3 electrons. So that is this reaction, minus 1284. Okay. K plus 1 did nothing in this part. Up here, last step. What is happening in this last step over here?
Solid से aqueous हो रहा है.
K plus solid से aqueous हो रहा है.
Achha, K plus solid, it's this one, right? K solid turning into K plus 1 aqueous, right? And that's minus 251. Like into 3 hoga, that's going to be minus 251 into 3. Because you've got 3 Ks and they're turning into 3K plus 1 plus losing 3 electrons. So it's going to be 3K turning into 3K plus 1 aqueous and losing 3 electrons. So ये बस आ गया cycle. You've created this other path. One of the signs need to change, and that's going to be this one. The arrow direction has to be changed. So if you go in this direction, it's going to be plus 2035. That's your other path. Minus 251 into 3. Okay, now that's minus 1284. See ya.
जी.
Minus 2.
I'm not sure what's the answer, but if it's minus 2. I mean, looks like minus 2, or looks like a very small value.
Minus 2, yeah.
Okay. Achha, what's the next one?
Missions part C3.
इसी का
नहीं, क्वेश्चन 6 पार्ट C3.
question number 6 parts. As a calculate the maximum mass of this acid that could be formed from 5 grams of in this reaction, give you answer to 3 significant figures. So calculate the maximum mass of this thing. Okay, and 5 grams of 2,3-dimethylphenylamine. So easy nahi hai. Like 5 divided by the MR. All you have to do is what is the MR? That's what you have to figure out. That's 6, 7, 8 carbon atoms. So that's 12 into 8. I'm trying to find the moles. Plus, how many? You've got 1 nitrogen, so that's 14. And how many hydrogens? That's 1 hydrogen over here, 1 over here, 1 over here. So that's 3 plus 3 plus 3. That's 9 plus 2, 11. So how many moles do you get for this?
0.0413.
That's 0.0413 moles. So if जो भी acid है, that will also have exactly the same moles, 0.041.
अच्छा, सही मैंने सही किया था.
बस वो into MR कर दो, ठीक है. But it's the whole इस तरह का question वो देते हैं because they want to check whether you can find the MR or not. And especially they're looking for, can you figure out the number of hydrogens? Because remember, benzene में carbon makes 3 bonds. So always remember that. Because the 4th electron is delocalized. So there's going to be just 1 H at this position. यहाँ पे भी there's 1 H.
Question 7 वो chromatography के ऊपर है.
अच्छा, question 7 ये basic O levels है. इसका कौन सा the whole question?
नहीं, बस the second part and वो Zwitterine वाली part on.
A second chromatograph of the same mixture is taken using a more polar solvent. ठीक है, predict the effect on the RF value of the amino acid. अच्छा, now remember कि amino acids, what are amino acids? Are they polar or not?
They are polar.
Yes.
ठीक है, they're very polar. They can form hydrogen bonds because they've got a carboxylic acid group, they've got an NH2 group. They're actually extremely polar because they've got they can form hydrogen bonds on both sides. अच्छा, anyways, Bella, the first solvent, what was the first solvent? Second. So did they give us any information about the first solvent? So even if they haven't, they're saying you've got a more polar solvent. So will the amino acid dissolve more or less in the solvent? Well, imagine the solvent traveling upwards, right? Is it going to be more soluble or less soluble?
Polar में ज़्यादा soluble होते हैं.
हाँ, ठीक है. So it's going to be more soluble. So that means it's going to travel more. It's going to travel a longer distance.
Higher RF value.
हाँ. Because the whole point about separation is that the solvent is moving. If solvent is the mobile phase, okay? So, and this is thin layer chromatography, okay? So remember, there are 2 types of chromatography that you have to study. So this is thin layer. What happens in thin layer is that the solvent is moving. So if the thing is soluble in the solvent, it will keep moving. And if whatever thing that is, the mixture, if it forms or gets attracted to the gel which is on the metal plate, then it will stop moving. So the gel on the metal plate, that's your stationary phase. If that particular substance particle gets attracted to the gel, then it will stop moving. If it's soluble in the solvent or if it's more soluble in the solvent, it will keep moving. So it's going to travel a longer distance. Okay, that's it.
Sir, what's the difference between stationary phase and solvent?
The solvent is the mobile phase.
तो decrease नहीं होना चाहिए because polar है, the more polar के साथ it will interact and it won't travel.
What is the solvent doing? It's traveling, right? वो travel कर रहा है ना. तो वो फिर it will remain part of the solvent. It will remain in the solvent, and the solvent is moving, right? So it will continue to move. ठीक है, मतलब उसी तरह ना कि आपने एक पानी है and you have thrown, let's say there's a मतलब जमीन में पानी फेंक दिया, अगर वो चीज if it's soluble in the water, then it will continue to travel with the water, right? If it's not soluble in the water, तो for example sand है, तो वो वहीं पीछे रुक जाएगी ना. Is that clear?
तो अगर वो कहते about stationary phase कोई और बात तो फिर ना होता.
If they could have asked कि the stationary phase is very solvent, oh sorry, very polar, or whatever gel coating that is put on this metal plate, if that gel coating was very polar, फिर क्या होता? फिर होता कि the particle would not be able to travel, because as soon as it starts to travel, it will stick or get attracted to the gel.
सही है.
ठीक है. I remember the question. There's going to be a lot of variation. Huh?
Sorry, sir, आप बोले.
नहीं, मैं वो कह रहा हूँ, there's going to be a lot of variation in the question, because sometimes they'll say the substance, whatever the substance is, that is non-polar. Sometimes they'll say that is polar. ठीक है. Sometimes they'll say the solvent is polar. Sometimes they will say the solvent is non-polar. Sometimes they're going to talk about the stationary phase, that it's polar or non-polar. So make sure, get the idea. Like if it's going to get attracted to the stationary phase, that means it's not going to move. If it gets attracted to the solvent phase, it will continue to move with the solvent, which is the mobile phase. ठीक है, is that clear?
Yes.
Yes, sir.
Lekin there's going to be a lot of variation. वो polar, non-polar, they'll keep mixing things up.
सर वो
उसके
जो ऊपर
next
वाला
page
MR
पे
का क्वेश्चन था, वो एक बार आप आखिर में सॉल्व कर देंगे, वो मुझसे I'm confused with that question.
चलो ठीक है, मैं करता हूँ. कौन सा? What's the next one?
So वो Zuterine वाली बात इसके next page हाँ ऊपर है इसके ऊपर.
अच्छा, this one?
Yeah.
Explain how draw the Zwitterionic structure of glycine. What is the formula of glycine? They've
1H के
one
साथ
H.
बस.
So the R group is the H. So you just draw glycine. The N lone pair will accept H+1, and the carboxylic acid would lose an H+1. So that is your structure. Explanation में बस यही होगा, the acid group ends up losing H+1 ions.
तो
And
वो नहीं बताना कि pH and isoelectric point वाली बात.
नहीं, it's in this question not specifically, because they're not asking for that. They're just asking how is this Zwitterine formed.
हम कहेंगे कि the carboxylic group loses an H and the amine group.
That's about it. That's about it. I mean, look at the marking scheme, but I think that you don't have to go into a lot of detail, because if this is 1 mark, पीछे क्या रह गया? That says you just left with 1 mark. So you just have to write a very basic explanation. Okay, the carboxylic acid groups produces a proton, and NH2 or the N lone pairs accept an H+1 and they act as a base.
So it's the E part.
So serine can react with alanine to form 3 different structural isomers, each with the molecular formula C6, H12 and 2O4. Draw the structure of the 3 isomers. So it's going to be both are amino acids, so it's going to be a peptide, like the first one. Okay. So he's saying they're going to react and they're going to form 3 different things. So first one, what is this thing? There's a CH with an NH2. So I'm just going to quickly draw. There's a CH, and it has an NH2, and on one side it's got a carboxylic acid, and the R group over here is CH2OH. I said the R group is CH2OH. So I focused on the central carbon atom. It had a C with an H and an NH2 and a COH on one side. So CH, COH, NH2, and then there was a CH2OH connected to the other side. So that's this one. So this other one is start with the middle carbon atom. That's CH, And again, it's got an NH2. And it's got a carboxylic acid on one side. And what's the R group? CH3, right? So the OH and the H would be gone from the middle, and they would form an amide link. Okay, there's going to be a condensation reaction. Is that clear?
Yes.
As a second one, the second one could be the other way around. Okay, this one comes on the left side and this one comes on the right side. I mean, switch the positions. So if I switch the positions, it's going to look like this. It's going to have a CH3. I will have a serial bond ONOH and NH2. And the second molecule, the first molecule would be on this on the right side. So that is CH. That's an NH2 and CH2OH. And double bond OH over here. So again, you'll have the OH would be lost, the H would be lost, right? And they would end up forming. So they would end up forming an amide link. So these two are different because these two are different because the NH side has a CH3 over here. The NH side has a CH2OH. Okay, ये तो clear? Is that clear?
Yes, sir.
So what's the third one? The third possibility is that one of your molecule has a carboxylic acid group, the other one has an alcohol group as well. So they can react together to form an ester link as well. So that is, that is not going to be a peptide because it's not going to have, it's going to be a polyester. It's going to have an amide link. So the third possibility would be the CH2OH group, right? That is the group that's going to double bond OH. And the other molecule's carboxylic acid. So what I'm going to do is I'm going to draw this molecule and I'll face the carboxylic acid on this side. So that carbon has an H and it has a CH3. And I'm looking at this one, it's got an NH2 on one side. So the OH and H would be lost and they would form an ester link as well. So in this case, you get an ester link.
ठीक है सर, पहले दो में अमाइड और आखिरी वाले में एस्टर. पहले दो वाले में अमाइड बना और आखिरी वाले में एस्टर.
हाँ. Well, the third possibility was, because I made two amides. Those are the only two possibilities. Like the order might be switched. And remember, in peptides, if you switch the order, you get a different thing. I mean, they kind of look kind of the same, but it's not exactly the same. Because the amide link is switched. The easier way to make the amide link is basically switched. Or the molecule is inverted left to right. What you had on the right side is now actually, this side is actually now present on the serial bond O side. ठीक है?
So question 8 is compound का नाम, how will we name it?
Yeah, it's a phenol. ठीक है? So this one is a phenol, baki, it's got 2 methyl branches and 1 chloro. So you've got chloro.
इनमें भी होता है एक precedence जैसे आपने AS में बताया था.
Usually you don't get questions that often on naming this. It's going to be very basic, okay? But just remember, if it's a like arenes have very little. I mean, it's similar to that. Okay, if I were to, there is no precedence actually, okay? But if I were to write a precedence, okay, in IUPAC nomenclature you don't have this. But if you were to write a precedence, just remember that that these alkyl chains, they don't have any precedence at all. Like if this was not an OH, you would call it methyl benzene. You will also call it chlorobenzene. It's going to be chloro and methyl benzene, both. Okay, so the molecule, wo jo suffix hai na, that doesn't depend on that. OH comes in, that changes the suffix. Instead of benzene, it's now a phenol. Is that clear?
Yeah.
So just remember that. Huh?
Numbering का इसमें कोई नहीं है?
Numbering
numbering
में वही है ना, if you make it a phenol, just remember phenol has the highest precedence. So OH is now 1. So OH is 1. So what are the positions of the methyl? It's going to be
3 chloro 2,4 dimethyl.
Okay, so it's 3 chloro and 2,4 dimethyl.
2,4.
But it's just remember that chlorine and these arenes, these carbon chains, they don't change the suffix. You'll still call it benzene. You'll call it methyl benzene or chlorobenzene. And
फिनॉल क्या प्रेसिडेंस रखते हैं?
hmm?
फिनॉल्स के अलावा और क्या प्रेसिडेंस रखते हैं? अगर OH हो, OH के अलावा कोई और चीज होती?
Apart from phenol, you have phenylamine. Okay, you don't have benzoic acid in your course, so you don't have pretty much most of the benzene related compounds. I mean, the other compounds are not even in your course, like benzoic acid, benzaldehyde. Okay, they're not even chapters in your syllabus, so they're not going to come. So the only thing you have to be prepared for is just phenols and phenylamine. Okay.
ठीक है, और उनसे नंबरिंग शुरू करेंगे.
हाँ.
ठीक है.
तो इसके आगे C part में Na के साथ the phenol will react.
हाँ, क्योंकि वो
Acid
phenols.
base reaction.
It's going to be a redox. Remember, metal plus acid is not an acid-base reaction. A metal reacting with an acid is a redox reaction. But if you have a metal reacting with, let's say, HCl, it's going to form NaCl. It's going to displace the H. But the acid is not behaving as an acid. What is happening is, because it's not producing H+1, it's actually producing H2 gas, which is basically H+1 getting reduced. +1 and now it's 0. Remember, this is a typical acid reaction, but it's not an acid-base reaction. It's actually a redox reaction. Okay?
सही है. And आखिरी वाला इसमें जो diazonium ion है, उसकी type of reaction is reduction.
For diazonium ion?
Yeah. With the compound.
Isn't it electrophilic substitution? I think it's electrophilic substitution. Where's the phenol, right? Iske saath hai na?
हाँ.
So what is happening is how do azodides form? It's an activated it's a diazonium ion, which is N triple bond N with a +1 charge.
Yes. And
it gets interested in, because of the lone pairs over here, which are overlapping with benzenes, the benzene electron cloud is like really dense. Okay? So what happens is this thing acts as an electrophile, and it gets interested in those electrons in benzene. So I think it's the same as electrophilic substitution, or not. क्या लिखा है उसका पीछे?
मैंने देखा नहीं सर.
So let me just quickly check. Yeah, this is definitely substitution because the H gets substituted by something, but let me just double check this one. One second.
May June 2019 photo.
It's electrophilic substitution. ठीक है?
सही है.
अच्छा और कौन सा इसमें?
बस सर खत्म हो गया।
ठीक है।
बस वो एमआर वाला क्वेश्चन एक बार मुझे उसमें कंफ्यूजन हो
फर्स्ट
रही थी।
कौन सा था? फर्स्ट था?
सर आई थिंक क्वेश्चन 3 था।
सर क्वेश्चन 2 था।
ये वाला?
नहीं सर ये नहीं, दूसरे वाला
जो
ये वाला था फिर? नहीं
यस सर ये वाला था।
वो क्वेश्चन
नहीं,
6 का था।
एमआर वाला ना, एमआर वाला।
हाँ वो क्वेश्चन 6 था। क्वेश्चन 6 पार्ट C3।
ये था हाँ। तो बस इसमें क्या था कि यू जस्ट हैव टू फाइंड आउट द एमआर, राइट?
एमआर तो हम खुद भी नहीं निकाल सकते मतलब देख के।
हाँ लेकिन आई थिंक the whole the question was very simple. Okay, you had 5 grams of this. You can find the moles of this, and it's 1:1, so you'll find the moles of this as well, and you'll just multiply it by MR. Okay, that's it. My only point was the purpose of giving this question is okay, they're just checking whether you'll be able to figure out the MR correctly or not. Do you know okay, in the skeletal formula of benzene, how many
यस सर
hydrogens are
वो
bonded
बाकी
over
उसमें
here?
हाँ एक ही हाइड्रोजन होता है।
हाँ मतलब ये बेसिकली एक भी नहीं होता, like over here there's not going to be any hydrogen. ठीक है, मतलब benzene makes carbon and benzene makes 3 bonds.
यस सर।
ठीक है, so this one has no hydrogen, this one has no hydrogen, but this one has one hydrogen. ठीक है, and this one would also have one hydrogen. ठीक है, तो वो बस मेरे ख्याल से in this question the question was very simple, but they're just checking whether you know how to calculate the MR correctly or not.
ओके
ठीक है, अच्छा
सर
अब
वो मई जून 20 वाले पेपर पे जा सकते हैं।
ठीक है, 1 सेकेंड। 4-1 जो था this one, right?
जी सर।
नहीं इस पे क्वेश्चन है पूरा करना है।
सर उसके अंदर बहुत क्वेश्चन।
अच्छा पूछो ना। नहीं कौन सा सारा करना है या कुछ स्पेसिफिक क्वेश्चन है?
सर बस स्पेसिफिक क्वेश्चन ही कर लेते हैं।
वो बता दो भाई मुझे।
अच्छा सर एक सेकंड। सर एक है ये क्वेश्चन 1 का पार्ट बी।
So one part B, when concentrated hydrochloric acid is added to a solution containing this, a blue solution is formed in the following equilibrium. Is used Lee Shackler principle to suggest the expected behavior when silver nitrate solution is added dropwise. What will silver nitrate, first thing, what will silver nitrate do? What will it react with? Silver ions, जो aqueous हैं, they're going to go and they're going to react with Cl ions. And together they're going to form a precipitate of AgCl.
White precipitate.
White precipitate would be formed. That's the first observation. A white precipitate would form. But what will happen to this equilibrium over here? What will happen to the concentration of Cl ions? It's going to decrease, right? Why? Because they're forming the white precipitate. Okay, so the concentration of Cl ions will decrease. Where would the equilibrium shift? The equilibrium would shift backwards. And if it shifts backwards, so this one is pink, while this one is blue. So the blue solution changes to pink. Plus there's going to be a white precipitate. ठीक है, is that clear?
जी सर। सर इसके बाद है पार्ट डी का डी पार्ट 2 1D पार्ट 2।
अच्छा, reacts with cobalt ions in a 1:1 ratio to form a new complex ion.
सर
Consider
1:1 का ये मतलब होता है कि मतलब कि अगर एक H2O मॉलिक्यूल है तो साथ में दूसरा मॉलिक्यूल भी वन हो दूसरा लाइगेंड भी वन होना
जो
चाहिए
मैं explain करता हूँ कि
वाटर।
उससे क्या कि ये ना this is CH, तो क्या these two react in 1:1. So what are you baat nahi kar raha? He's talking about the whole thing. This whole thing reacts with this whole thing in 1:1. So it's basically copper with cobalt with 6 water molecules, and it's reacting with exactly 1 C6H18 N4. So what does that mean? What will be the reaction? The reaction will be and he's already told you that it's a tetradentate ligand. So what will happen is this molecule is basically going to replace how many water molecules? If it's a tetradentate ligand, क्या होगा?
3 उसके बनेंगे and 3H2 के.
नहीं मैं so एक second. 3 नहीं होगा. Tetra. What does tetra mean? 4. ठीक है. So what is happening is you've got 6 water molecules initially, right? So let's say you've got 6 water molecules. Now, if this tetradentate ligand comes in, remember the ligand, why is it tetradentate? Because it's got it's a big molecule and it's got 4 lone pairs at 4 different positions. So 4 of the water molecules, because it's a tetradentate ligand, 4 of the water molecules are going to get knocked out. And this big one, if I draw it like this, so this tetradentate ligand is going to come in and it's going to replace the 4 water molecules. This entire thing. You read one and think of this as this thing. So it comes in and replaces the 4 water molecules. Is the idea clear?
Yes, sir.
This matlab, what is the product that you're getting? The product that you're getting is you now have cobalt. Or the remaining water molecules are 2. And what else has gotten attached to it? C6H18N4. One of this big ligand tetradentate comes in, bonds with it, and the 4 water molecules they get replaced. ठीक है? तो थोड़ा सा सोचना था इसमें, मतलब you can't just tell directly what is happening.
Sir, 3 का part 1 उसका half equation है.
अच्छा 3 part 1 नहीं ये तो बहुत मुश्किल है. अच्छा ये वाला मुश्किल है. This one is difficult. What happens here is you should know how to make, like how do you make half equations. ठीक है? There are 2 steps. Like we'll go in one direction. Like if I have 2 reactions, I've got Al3 plus, let's say plus 3 electrons, and it's forming Al. And I've got another reaction, Na losing electrons to form Na plus 1 electron. Okay? So let's say these are the 2 half equations. So how do you make the full equation? Reduction plus oxidation. The first thing is you balance the number of electrons gained and lost. So what you're going to do is you're going to multiply one of the reactions by 3. And once you do that, then you add up the reactants and the product. So it's going to be 3Na plus Al3 plus, and the product is going to be 3Na plus 1 plus Al. And the electrons on both sides would get cancelled out. So things that are common on both sides, they get cancelled out. Okay? So I just wanted to show you how do you add up 2 half equations and how do you make the full equation. Now in this question, we're going to try and go in the opposite direction. Okay? We're going to do the opposite now. So this is my full equation. This is my overall equation. And this over here is my oxidation equation, right? So there's going to be an oxidation equation and there's going to be a reduction equation. And these 2 equations will add up. So you're going to add them up and that will give you this. The idea clear? Is this clear?
Yes, sir.
Achha, so the reactants will add up to give you this and the products will add up to give you this. So let's focus on the reactants. You've got 2 water molecules, right? So what needs to be added to, so I'm just focusing on the left side now. And remember, there's another equation which I don't know what that equation is, but that equation will also have a left side. Okay, so यहाँ पे नहीं था AL3 plus gets added to Na, and then you get this overall equation, right? So we're trying to do the same thing. Now the first thing is one of the equations needs to be multiplied. The electrons gain and loss, they need to be equal. So if I look carefully, यहाँ पे how many O2s do you have? You've got 6 O2s, right, in the products. So what do you think this equation is getting multiplied by? But how do you?
Either 3 or either 6.
Probably 6, because how do you get 6 O2 in the product? Like there's going to be 6 O2s over here, okay? So I'm going to multiply this by 6. So there's going to be 12 H2Os and 6 O2s, and over here I'm going to have 24 H plus 1, and I'm going to have 24 electrons. Is that clear? Okay, why did I multiply this by 6? Because I need 6 O2 in my product. So one of the equations is going to give me 6 O2s. But this equation over here was only giving me 1 O2. So I multiplied the whole equation by 6. And remember, that was one of the process when you're adding up or making the equation. Beach mein you would multiply some of the equations by some number, right? So over here, I think this equation before getting added up was getting multiplied by 6. You clear?
Yes, sir.
So now next part. So I've got 12 water molecules. So what needs to be added from this other equation that I get 6 CO2? So this other equation will have 6 CO2s, right? Is that clear?
Yes, sir.
But if I add this with 12 H2Os, I'm going to get 6 CO2s plus 12 H2Os. I don't want 12 H2Os, I want 6 H2Os. So I'm going to put a minus 6 H2O over here. Because your left hand का जो sum होगा ना, that should come out to be 6 CO2s plus 6 H2Os. But over here at the moment, if I put 6 CO2 in this other equation, यहाँ पे there is 12 H2Os. So the thing will not give me this left hand side. So I need to subtract 6 H2Os as well. So maybe there's a minus 6 H2O on this side. Okay, so that is what I'm predicting on this side. Let's move to the other side. I've got 6 O2s, right? So I've got 6 O2s. So this other equation is bringing in the C6H12O6. Okay, is that clear as well?
Yes, sir.
Okay, so that was the left hand side. Now I'm focusing on the right hand side. So C6H12O6 plus there is 6 O2s. So that gives me this. Plus there is 24 H plus 1 and 24 electrons as well. I need to get rid of that because there is no 24 H plus 1 or 24 electrons on this side. So I'm going to subtract it over here. 24 H plus 1s. And I'm going to subtract 24 electrons as well. So I'm going to subtract that. Now if I add the right side, there's 6 O2s plus C6H12O6. So that gives me my final equation. There's 24 H plus 1 and 24 electrons in this equation. So the other equation must have minus 24 H plus 1 and minus 24 electrons. So if I add them up, that gets cancelled out. So I figured out my other half equation. The only thing I need to do is I need to rearrange it, because you don't have equations where you have minus 6 H2O. So what I can do is I can get the H2O to the other side. So it's going to be C6 CO2 and there's going to be C6H12O6 plus if I bring the 6 H2Os on the other side, that's going to be 6 H2Os. And minus 24 H plus 1 minus 24 electrons needs to be taken to the other side so that it becomes plus 24 H plus 1 and plus 24 electrons. So that's my final half equation. You clear?
Yes, sir.
तो है, लेकिन मैं शुरू में जो आपने पहली इक्वेशन को 6 से मल्टीप्लाई किया है वो नहीं समझ आई।
नहीं कि पहले को 6 से क्यों मल्टीप्लाई, ये समझ नहीं आया। वो इसलिए ना कि my product has 6 O2s, right? तो जैसा ये है ना, let's assume I had this and I was trying to figure out let's say I was trying to figure out what is the actual half equation over here. They gave us this half equation. Like if the final equation has 3 Na plus 1, that means before adding them up, this was actually getting multiplied by 3, right? That's why you got 3 Na plus 1 over here. Okay, so 6 O2s aa raha tha, yahan pe there was only 1 O2. So that means before adding up, this was getting multiplied by 6. Okay.
सर इसके अगले पार्ट में ये जो 1 मोल डीएम क्यूब और 1 एटीएम कंडीशन होगी, ये स्टैंडर्ड हाइड्रोजन की होगी या दोनों इलेक्ट्रोड्स की होगी?
कौन सा पार्ट?
सर ये जो इसी का अगला पार्ट 2 है डायग्राम वाला, तो उसके अंदर डायग्राम में स्टैंडर्ड हाइड्रोजन इलेक्ट्रोड का 1 एटीएम और 1 मोल डीएम क्यूब कंडीशन होगी या दोनों की होगी?
क्योंकि ई नॉट मेजर कर रहे हो ना, ई नॉट आ गया ना ऊपर, दैट मींस स्टैंडर्ड कंडीशंस फॉर एवरीथिंग.
ओके सर, इसके बाद 5 पार्ट ए.
Sir, I have a question. I made an equation, but it's a little different than yours. I made 6 CO2s plus 12 H plus 12 electrons, and on the product side, I'm getting.
Why did you get 12 H plus 1?
You multiply the first equation by 6, but I considered the water molecule. Like you have 2 water molecules, you have to multiply it by 3 to get 6.
I wanted to make O2 6.
And I made water molecule 6, and I'm getting an.
But then अच्छा चलो ठीक है, that would make sense. That would make sense on the left hand side, right? Okay. But how would you add? I mean, these are your 2 equations, right? One second. That's your one equation, and that's your other equation, right? Now the problem is, if you multiplied this by 3 instead, like you did, then oxygens would be 3 O2s, right? So you will never get 6 O2s in the overall equation.
Like 3 O2s on the product side.
Huh?
Like I'm getting an extra 3 O2s on the product side.
So you're not going to get this overall equation, because the O2s have to be 6 at all cost. What you did was you added O2s over here, right?
Exactly.
Actually, the problem with that is, if you let's say I did what you did, right? If I had added O2s over here, then what is happening to O2? O2 is -2 over here and O2 is 0 over here, right? So that is getting oxidized. So that's now an oxidation equation. So we were looking for the reduction of carbon dioxide. Is that clear as well?
Yeah.
Okay, that's the reason you can't do that, because if you started adding O2s on this side in this equation, then it wouldn't be a reduction equation. It would actually turn into an oxidation equation. So you can't bring in O2s.
A का part 2 आप एक बार करा सकते हैं?
Part 2?
Yes sir. इसके अंदर I'm kind of confused how to solve this.
आवाज कम आ रही है, क्या ऊंचा बोलो?
Sir, मैं कह रहा हूँ इसके अंदर I'm kind of confused how to solve this. If you can help me out.
Need drawing the electrodes, right?
Yes sir.
One second. As this way, draw a fully labeled diagram of the apparatus that standard electrode O2, E0 O2 in half equation 1. So he's talking about this equation, right? So it's water, O2 and H plus 1. He's talking about this equation. So जब भी gas होगी, O2 is a gas, right? So for a gas, you need a gas jar. So there's going to be O2 gas coming in at what pressure? At 1 atmosphere pressure, right? There's H plus 1 and water as well. So the solution will have H plus 1 ions, water aqueous. I mean, you don't have to write water because that's obvious when you write aqueous. There's going to be a platinum electrode. ठीक है, remember, whenever you have a gas and aqueous ion electrode, so whenever you have a gas and aqueous ion electrode, this is the electrode that you're going to make. You're going to make a platinum electrode with a gas jar. The gas will be in the gas jar and the aqueous ions would be in the aqueous solution. Okay? You clear the first half cell. This is the oxygen electrode. Is that clear?
Yes, yes.
Yes, sir.
Or here you had to measure the potential of this using you have to measure the standard potential. How do you measure the standard potential? You measure it with respect to the standard hydrogen electrode. So on the other side, you'll have another platinum electrode. You'll have a gas jar, and that gas jar will have hydrogen gas in it, 1 atmosphere pressure, and the solution will have each positive ions.
सर इस क्वेश्चन में हमसे दोनों मांगे हैं ना, सिर्फ एक ऑक्सीजन का हाफ तो नहीं मांगा ना?
दोनों मांगे क्योंकि नहीं, एक सेकंड. Draw a fully labeled diagram of the apparatus that could be used to measure the standard electrode potential. So if you want to measure the standard electrode potential, you have to draw the whole diagram. And there's one thing missing, that's your salt bridge. तो बस labeling कर लेना platinum electrodes.
कौन सा salt bridge?
नहीं. No one is going to ask you about that.
Okay.
ऐसे सिर्फ क्वेश्चन 5 पार्ट है.
5-part why no addition reaction takes place. Benzene reacts with bromine in the presence of an aluminum bromide catalyst to form bromobenzene. No addition reaction takes place. Explain why no addition reaction takes place. Well, what's the reason for that?
Yeah.
Whether you have a benzene or where you've got H's. So why no addition takes place? Logically, let's look at the mechanism. Okay? Let's focus on this carbon atom. It has an H. Okay? You've got a Br plus 1 coming in. Well, you had a bromine molecule, right? But the bromine molecule got polarized by the AlBr3, and that AlBr3 attracted electrons from one of the Brs. TK, so one of the Brs went and got attracted to that Al, right? And you're left with a Br positive. Now that Br positive is interested in the benzene electrons. So what it does is each carbon atom is forming a pi bond. So it goes and attacks that particular carbon atom, and this Br plus 1 goes and bonds with it, right? And a positive ion is formed. So the question is, why is this not an addition reaction? I mean, why in the next step, H has to lose electrons? So one of the reasons I can think of is that this ion is very unstable. I mean, the reason what he's talking about is, why don't other bromines come in and they start doing the same thing? Like maybe another Br comes in, steals another electron. So the problem is, what I think the problem is, that once one Br takes away electrons, this ion is very unstable. The positive charge density is really high, and it needs electrons back. So it goes and takes or pulls away electrons from the H. The reason why addition is not possible is because it would be very hard for somebody, for some other Br plus 1 to come in and steal more of the pi electron clouds. Because once there is a positive charge, that positive charge needs its electrons back. वो double bond की तरह नहीं होगा. Like you have a double bond, right? In double bond, the electrons were very few, but over here the pi electron cloud is really big. There are 6 p orbitals which are overlapping. So the Br plus 1 has to steal a lot of electrons ताकि वो the pi bond or pi electron cloud finishes. That would be very hard because every time they pull away electrons, there would still be a lot of pi orbitals, pi bonds left. So, and the positive charge would build up. So one of the reasons why no addition is possible is, and why substitution happens is, why does the H have to lose electrons, is that the ion formed is very, very unstable or has a greater charge density. Is that clear?
ओके सर ठीक सर इसके बाद ये 5 का सी पार्ट 2 सर वो आसान तरीके से कोई करने आसान तरीका नहीं है कोई करने का इसको
बस यही है और
सी पार्ट 2
यही है
नहीं दूसरा सी पार्ट 2
अच्छा सी पार्ट सॉरी अच्छा सी पार्ट 2 is के you've got 13 वाला तो वैसे ही आसान है वैसे क्या नंबर ऑफ पीक्स
सर इसके अंदर लाइक वो पेज ढूंढने में बहुत टाइम लगता है और सर मैं एक दूसरी चीज पूछ रही थी कि सर ये जो राइट साइड की एक चेन हम लोग लेफ्ट साइड पे लगा सकते हैं या नहीं सारों को राइट साइड
मुझे
पे
एक तो
होना
क्वेश्चन
चाहिए
एक सेकंड let me try to understand the question. I don't know what the question is. The question is there are 4 different carbocations with the same formula C4H9 plus. Acha, theek hai, that makes sense. So I think in this question what is एक second sorry. Acha, so I think in this question what is happening is the electrophile is now C4H9 plus. And he's saying that there are 4 different carbocations. So remember, this thing would remain intact. I mean, this is coming in as one thing, one entity. Clear? But what you're saying is to split this up. So this is what's happening. C4H9 plus, right? So how many different C4H9 plus are possible? One of them would be there are 4 carbons and this carbon is a plus. You can add in the hydrogen.
सर ये नहीं इससे नीचे वाला पार्ट
नहीं मैं इसी पे आ रहा हूँ ना स्ट्रक्चर्स के ऊपर ना
ओके
ठीक है so one of them is this one so that means there's going to be a benzene right and this C4H9 plus ठीक है I'm just ignoring the hydrogens it's going to come in it's going to steal electrons and it's going to bond at some position ठीक है ये clear that's the first one
जी सर
Achha, but remember this is one entity what is the other version of this the other version of this the same version of this thing maybe achha, maybe you still have a 4 carbon atom C4H9 but the middle carbon atom is the carbocation you don't know where the positive charge is right so maybe it's on the second one so if it's on the second one so you've got a benzene and you've got a 4 carbon atom chain and the second one is the positive one so if it comes and gets attracted to this C4H9 plus so the benzene will bond with the carbon that's on the second one okay so this would be different from this Achha, what else C4H9 plus what other options do you have so maybe there could be another one Achha, I'm ignoring this at the moment we'll fix that later at the end Achha, another one is maybe the 4 carbon atoms are branched and this carbon atom is the plus one so the benzene goes and bonds with this carbon atom so you get so just one second so you get this you be clear or
जी सर
the last option is the last option is you've got 4 carbon atoms C4H9 and the middle one is the positive one so the benzene goes and bonds with this so with this middle carbon atom so these are your 4 structures now you can sort of rearrange them according to the NMR spectrum okay this one has 6 peaks let's try and figure out how many peaks each one has इस case में this is going to be 1 ठीक है this is different from the others right this is going to be the 3rd frequency this is going to be the 4th frequency all 4 carbons are different I mean this carbon is bonded to benzene this one is bonded to 2 carbons this one is at the end so that's different Achha, फिर इधर आ जाते हैं you've got this carbon that's going to be your 5th peak I said these two are exactly the same. And these two are exactly the same as well. And this one is going to be your 8th. So this molecule is, I think, this one. Achha, what about this one? How many different carbon environments do you have? This carbon, and this carbon are identical. So they would all resonate at the same frequency. Okay, let's call that 1. This one is different, so that would resonate at frequency 2. This is going to resonate at frequency 3. These two are exactly the same, so frequency number 4. These two are exactly the same, and this is different from the others. So 6 peaks. So this is this one. Okay, last one, that's the last one. I mean, these two are exactly the
सर
same.
मुझे पता ही नहीं था कि ऊपर वाला क्वेश्चन और ये वाला जो ये दोनों रिलेटेड है.
हाँ, मतलब वही क्वेश्चन इंटरप्रेट नहीं किया होगा क्योंकि डिफिकल्ट था कि I mean you had to think कि this question was difficult comprehension wise, like you had to sort of link this up. Okay, you got a C4H9 plus 1 coming in, so how many different ways will the C4H9 plus 1, and you don't even know what the C4H9 plus 1 looks like, whether it's 4 carbon atoms and the plus 1 is at the end, or it's on the second one, or it's branched. Okay, or branches, maybe there are 2 options, whether the plus 1 is over here or the plus 1 is right in the middle. Okay, but ये question मुश्किल था, it's a difficult question.
सर एक दूसरा है 6 part B.
ये भी वो है कि you just, but if this paper is like really tricky, क्योंकि बहुत सारे questions आए इसमें अजीब. I said this one is कि you've got K of values are given. Ethanoic acid, ठीक है? What is the K of ethanoic acid? Ethanoic acid is this thing. So it forms H plus 1 and HCOO minus 1, right? So the K expression would be product concentration, and let's call this K1, okay? So it's going to be product concentration divided by the reactant concentration, which is HCOOH. That's the next one, which is this one. This is, they gave you the K value for this one as well. So this is CH3 CO COOH. Okay, if it ionizes, it's going to produce CH3 COO minus 1 plus H plus 1. Now the K expression would be -1 concentration into H plus 1 concentration divided by so this is K2, this is K1. So I've gotten both expressions. Now the question is, I mean, this data is apparently not linked with this one. What he's saying is, find the equilibrium constant for this reaction. So apparently this thing is not linked with, I mean, if you read the question, it looks like this thing is not linked with this one, but it is. Okay, he's asking for the equilibrium constant for this reaction. So if I write the expression for equilibrium constant, so it's going to be product concentration, HCOH concentration, into the other product, which is CH3 COO minus 1 concentration divided by HC reactants, HCO minus 1 concentration, and CH3. So they're asking you to give you a value of this, and they didn't even tell you that you're going to use those values. Okay? So how are the 2 expressions linked? How is K1 linked with K2? I mean, how is K equilibrium? I mean, you know these values. You know this is 1.78 into 10 to the minus 4. This one is 4.07 into 10 to the minus 3. So you know these values. How do you link this with these 2? But if you look carefully, then it's basically K2 divided by K1. Like if you take this and you divide it by this expression, you're going to get this expression, I think. Okay.
Oh, okay, sir.
So that means it's going to be 4.07 into 10 to the minus 3.
Divided by what?
And you're going to divide it by 1.78 into 10 to the minus 4. Okay, you'll get your answer.
अच्छा सर, ये इसके बाद इसी का पार्ट सी है सर। इसके अंदर जो है ये मेरे ख्याल में मेथनोइक एसिड है और उसके साथ जो दूसरा एथेनोइक डायोल है या जो भी है सर, इन दोनों के लिए डिफरेंट वो है। तो सर इन दोनों के लिए डिफरेंट वो क्यों है रिएजेंट्स?
मैं एक्सप्लेन करता हूँ एक सेकंड। किधर है वो चार्ट? ये वाला। अच्छा, methylic acid and ये ethane dioic acid, remember this, these two get oxidized. And अच्छा, these two get oxidized. और ये इनका oxidation का, remember this, methylic acid reacts with KMNO4, K2Cr27, toluenes or phthalings, and it gets oxidized to carbon dioxide and H2O. These are the only two acids that actually get oxidized. And you also have ethane dioic acid, which gets oxidized by KMNO4, but only KMNO4. So if you go back to the question, what's the question? Just hold on 1 second. So if you go back to the question, these other two are not reacting, while this one is reacting, right? So so I think you can add phthaling or toluenes.
Oh, okay, sir.
Okay. Even other organic acids, they don't react. So this one, I mean, they don't get oxidized. So this one is obviously out of the question. It's not going to react. These are the only two that get oxidized, but they get oxidized by different reagents. I mean, both of them get oxidized by KMNO4, but this one can get oxidized. The first one can get oxidized by toluenes or by phthaling as well. So then in the third one, it's this one that's reacting. So the only difference is this one is a ketone. So what you can do is you can add 2,4-D in pH. So the ketone part will react. And the last one, both of them are reacting. So both carboxylic acids can get oxidized by KMNO4. Acidified and reflux. Is this clear?
Sir, but 2,4-D in pH के साथ तो मेथनोइक the first one वो भी react नहीं करेगा.
No, that's a carboxylic acid. 2,4-D in pH only reacts with aldehydes and ketones.
Okay.
But if it has C double bond O only, okay, if it has C double bond O and OH, then there's not going to be a reaction. That's a carboxylic acid.
Sir, अब इसी का part E.
Part कौन सा?
Part E.
Part E. That's a enema is proton enema. Proton enema is H enema. Remember that. Okay, so second, use the proton enema spectrum F to complete the table. So I'll just analyze this very, very quickly. Okay. So you've got the shape of the peaks. Okay. The relative height is going to be 3. Like, is this going to be a triplet or a doublet or a quadruplet? Kya hoga?
Triplet.
Okay, so this one is a triplet. Or this one is going to be a quadruplet, right?
Yes.
And that one over here, ye kya hoga? That's going to be
Singlet.
Singlet.
bas theek hai. So you've just figured this out without even looking at the data booklet. Okay. So this one is this one. Quadruplet is the quadruplet one is this one, and the triplet one is this one. Okay. As remember, zero pe that's TMS. I mean, that's your reference. That's your. I mean, that is irrelevant. Okay. Just don't focus on the zero. That's just used as a reference. So, but you've figured this out. So, बाकी fill the
सर
table.
इसके बाद ये जो नंबर ऑफ H atoms रिस्पॉन्सिबल है सर यहाँ पे वो सिंगलेट के लिए
3, 2 and 3.
सर उसके सिंगलेट के लिए भी 3 वो किया हुआ है 3 किस तरह आ रहा है सिंगलेट के लिए 1 H रिस्पॉन्सिबल
3 H.
अच्छा सर यहाँ से वो किया हुआ है
और remember कि इसको दो तरीकों से they call this the relative area of the peaks or relative. Sometimes they refer to it as the relative area or they refer it as the relative height. ठीक है, and they also अच्छा ये case तो simple है. They just told you that find the number of H atoms. ठीक है, this thing also means the same thing. You've got 3 H atoms in this. You got 2 H atoms in this one, and you got 3 H atoms in this one. And also remember, if the peak splits, the height decreases because now it's distributed. It has the same area. Okay, iska bhi, this one is 3, and this one is also 3. But when a peak splits, then automatically the sort of it spreads out. Okay, so the area is the same. If I collect all the 3 smaller peaks, it's going to have exactly the same height.
सर इसके बाद वाला पार्ट है F part F.
Circle the protons that show peaks in both NMR spectra. Explain in both which NMR. Acha. So, acha, you've got mic. Acha, so you've got D2O. This is about D2O. Remember, when you add D2O, which hydrogen atom or proton gets displaced?
OH.
Okay, it's just OH and NH2, right? Also NH2. Okay, their protons, they get replaced by D+1 ions. So in this case, the NH2 and the carboxylic acid OH, they're both going to be displaced by D. So instead of, you're not going to have carboxylic acid, you would instead have COOD. D is also H, but it's just an isotope of. And the same thing happens with the NH2 as well. It would be ND2 now. Okay? And D does not resonate. So these 2 peaks would be gone. Clear? Deuterium.
जी sir.
Deuterium has even numbered nucleons. So its magnetic poles dipoles are paired. So it doesn't show any overall dipole.
Sir, इसके बाद question number 7, part 2. A part 2.
Question number?
7A part 2.
Take it one second. Calculate the equilibrium concentration of silurians in a saturated solution of Ag2CO3. So you've got Ag2 as a CO3 solid. Or it's going to dissolve and it would form ions, Ag+1 aqueous in saturated solution. 2 silurians would be produced and 1 carbonate ion aqueous would be produced. So your Kp expression would be what? It's going to be silver ion concentration that's going to be squared, and it's going to be carbonate ion concentration, which is going to be power 1, right?
Mm-hmm.
So silver ion squared and carbonate ion power 1. Now you know the Kp value that's already given. That's 6.3 times 10 power minus 12. What you don't know is the concentration of the ions. So let's say X mole per dm cube dissolves, right? So it's going to produce 2x mole per dm cube of silver ions, and it's going to produce X mole per dm cube of carbonate ion. I don't know how much silver carbonate is actually dissolving in the solution. So if X mole per dm cube dissolves, 2x mole per dm cube of silver ions and X mole per dm cube of carbonate ions are going to be produced. So the concentration of silver ions is going to be 2x. So it's going to be 2x squared. And the concentration of carbonate ions is going to be, X. So you solve for X and then you figure out the concentration of silver ions using X.
सर वो वाला कौन सा क्वेश्चन होता है जिसके अंदर KSP को हम AG को फाइंड करने के लिए हम KSP की वैल्यू को मल्टीप्लाई बाय 2 और स्क्वायर करते हैं सर वो सॉल्युबिलिटी फाइंड करने के लिए करते हैं वो कौन सा क्वेश्चन होता है सर मैं उसको हमेशा
नहीं ये भी वही है ना, so we're trying to find solubility, you're doing the same thing. Like how do you find
तो
it?
इसके अंदर तो पहले हम सेपरेटली x फाइंड कर रहे हैं ना हम उसको वो क्यूब रूट ले रहे हैं सर उसके अंदर हम डायरेक्टली मल्टीप्लाई करते हैं
वो ना उसमें वो हमसे KSP पूछने को कहते हैं जो तुम कह रही हो ना उसमें दे आस्क अस फॉर द KSP नॉट द सॉल्युबिलिटी
हाँ वो फिर दो मैं बता देता हूँ there are two types of questions, ठीक है? One is they might give you the concentration. Let's say they tell you that it's 0.0012 mole per dm cube that's dissolving, right? That's the solubility. So if it's dissolving, so you would know okay, the concentration of silver ions would be 0.0024 mole per dm cube, right? And this would be 0.0012 mole per dm cube. And then you use these values, you put them in the expression and you find KSP. Okay? There's just two questions. Okay? One is this one, the other one is the opposite one.
ओके अच्छा सही है
ठीक है
मैं इसको हमेशा कंफ्यूज करती हूँ और सर इसके बाद ये वो वाला है क्वेश्चन 8 का ये बफर सॉल्यूशन का pH और एक मिनट सर
ये वाला this one
जी सर
in this question they're talking about NH4 plus 1, so it's probably acting as an acid. Okay? So it's NH4 plus 1. It's going to produce, if it loses an H plus 1, it would produce NH3. So that's your equation. And your K expression would be H plus 1 concentration into NH3 concentration divided by the acid concentration, which is NH4 plus 1. As in now, the part 2 karna ya direct part 3? I mean, we'll do.
So best part 3.
As a part C is numerical value of K is this thing. So you know that this thing it has a value of 5.6 into 10 to the minus 10. As a buffer solution was produced, as the question is slightly more complicated. Okay. The buffer solution would be produced after this reaction. First thing you're going to talk about this reaction. There's a reaction that's happening. NH3 is reacting with HCl. So what is the product? The product that's going to be produced is going to be, it's going to be NH4Cl. Okay, so you will have a reaction first. What is the amount of ammonia that's, mujhe moles bata do. How many moles do you have? 0.8 into 0.25 divided by 1000.
सर मैं इसको कंसंट्रेशन से करने की कोशिश कर रही थी तो मैंने मोल्स नहीं निकाले थे
अच्छा नहीं मोल्स निकाल पहले तो वो निकालना है कि what happens, what is the situation after this reaction. So 0.8 into 0.25 divided by 1000.
Sir, 0.2.
0.2 moles. Achha, HCl, how many moles of HCl do you have?
0.04.
0.04 moles. So it means which one is in excess? 0.04 is going to react. Okay. And it will react with how much? 0.04. So if it reacts with 0.04, so how much NH3 is left? That's 0.16 moles. Okay. So 0.04 is going to react with 0.04 and it will produce 0.04 moles of NH4Cl. You clear? So
एक से 0. अच्छा सही.
but the excess में था ना, this was an excess, right? Because it's 1:1, na? So 0.04 will react with 0.04. So out of 0.2, 0.04 will react. So you're still left with 0.16 moles. So at the end of the day, your container has there's 0.04 moles of NH4Cl getting produced. And then there is the leftover NH3, which is 0.16 moles. So I'm now going to link this up with this thing. Okay, what does my container have? It has NH3, which is 0.16 moles. Okay, so I've got 0.16 moles of NH3. And I've got how much NH4 plus 1? I've got 0.04 moles of this thing. So use those values, put them in the expression. They gave you I think they gave us the K value. So I'm just going to put everything in the expression. 5.6 into 10 to the minus 10 is equal to H plus 1 concentration into NH3 concentration, which is 0.16.
But say ये तो moles नहीं है.
मैं बताता हूँ एक second. I said, in this case, you don't have to find concentration. To find concentration, you would have to divide by volume, right? You clear? You have to divide by volume.
But say ये concentration दी नहीं है 0.25.
खत्म हो गया ना, वो तो reaction हो गया, वो तो अमोनिया के मोल्स ही कम हो गए.
Oh.
ठीक है.
Oh.
So this HCl की concentration was given as 0.2 now, but HCl is gone after the reaction, so its concentration is now 0. So, but the point is that you can directly use moles because dividing by volume is irrelevant. Okay, if you divide by volume, or if नीचे भी you also divide by volume, the volume term will get cancelled out.
ठीक है सर, फिर वो expression में डाल देना.
Sir, can you please explain this one more time?
मैं बता देता हूँ कि ये था ना कि this was your acid equation ना कि you had NH4 plus 1. उससे कहा it has a Ka value. K is for acids, right? So what is the general equation for an acid? An acid is something that produces 1H plus 1 ion. I mean, the K is for this expression. Okay, it produces 1H plus 1 and produces something else. So he gave you a K for this thing. So it's NH4 plus 1 and it releases. So it's going to release H plus 1 and produce NH3. Okay, that's how it's going to behave as an acid. K jo hota na, that is an acid dissociation constant. Okay, you clear that that's the expression that you're going to get. And,
yes, sir.
And they told us to write the expression. So it's products over reactant. So it's H plus 1 into NH3 divided by NH4 plus 1. Next step jo tha na, that was okay, they told us that NH3 is reacting with HCl. So this thing has nothing to do with this equation. First, there's going to be a reaction. Okay, NH3 ke moles were 0.2 moles that were added and HCl was 0.04 moles. So NH3 was added in excess. So there's going to be a reaction 0.04 of HCl. NH3 and HCl react karte hain na, they end up producing NH4Cl. So 0.04 moles will react with 0.04 moles of this and it will produce 0.04 moles of NH4Cl. So there's a reaction going on. So in the reaction, 0.04 moles of NH4Cl are going to be produced. And when 0.04 reacts with 0.04, तो पीछे कितना बच जाता है 0.16 moles. So there's a lot of leftover NH3 as well. So your container has two things now. It has NH4Cl and it also has NH3. So if your container has NH4 plus 1 ions, जो कि 0.04 moles है, and it also has NH3 which is 0.16 moles. So basically now after the reaction, it is this equilibrium that we're talking about. You clear?
Yes, sir.
So I just used, because they were asking you to calculate the pH value. So I just added, I knew the concentration of NH3, okay, moles, I knew the moles, I knew the concentration of NH4 plus 1 in the solution. I just put them in the K expression and I found I'm going to get H plus 1. Okay.
Sir, question 9 part A or part B?
It's a 9 part A. The manganese oxide catalyzes the decomposition of the mechanism involves the formation of the species Mn2 plus in the first step, which is subsequently used up in the second step. Use relevant electrode potentials, to construct two equations for the show how. So they're saying that MnO2 is the catalyst, right? So what that means is, that it's reacting. I mean, how does a catalyst work? There's one reaction that we have done so far, one mechanism that we have to memorize. I'm just going to use that and I'm going to compare it with this one. Okay, so there was this S2O2 minus reaction where it's gaining 2 electrons. It's in equilibrium with 2SO4 minus 2. And the E naught for that is 2.01 volts. And there's another one which is I2 plus 2 electrons in equilibrium with 2I minus 1. And the E naught is for this, it's 0.54 volts. A higher potential gains electrons, lower potential loses electrons. And if you do that, you're going to get a reaction which is going to be S2O2 minus or 2I minus 1. And it would produce 2SO4 minus 2. And it would produce I2. What was the reason that I said that this reaction does not happen, even though it's a very feasible reaction?
High activation energy.
And why is there but it is high activation energy, but why is there high activation energy? Okay. Both ions are negatively charged. So they're going to repel each other. They're not going to interact with each other. They're not going to collide with each other. So there's not going to be any reaction. So we did this example. So what we did next was we knew this reaction does not happen in one step, but the reaction can happen in 2 steps. How can it happen in 2 steps? That you add, that this thing does not react with this thing because both ions come out to be negative. They're never going to meet. So instead, what you do is you add Fe ions as catalyst. When you add these ions as catalyst, and this is 0.77 volts, when you do that, the Fe ions, they independently react with both of them. These two will react. Okay, let me multiply this by 2. So these two will react and they'll form a reaction where I think Fe is the lower potential, so it loses electrons and the other one gains electrons. And then the Fe ions will also react with iodine, but in that case, iodine is the lower potential, so it loses electrons and the Fe ions gain electrons, right? So you get 2 separate equations, and the overall change in Fe remains the same. Okay, so we're going to use the same analogy, same exact analogy for this reaction. That's the overall equation. So what they're saying is the mechanism, so they've added MnO2 as the catalyst. So they're saying the mechanism involves the formation of the species Mn2 plus in the first step. So if I have the data booklet with me, then I know where's MnO2 and Mn2 plus. So I know K, where's Mn? This one. So I have this equation, 1.23 volts. So MnO2, and he's saying that MnO2 turns into Mn2 plus. So if you go back to the question, it's MnO2 plus 4H plus 1 plus 2 electrons. So I'm going to write that MnO2 plus 4H plus 1 plus 2 electrons. It's in equilibrium with Mn2 plus. And what else? Plus 2H2O. And this is 1.23 volts. Now he has told us that the mechanism involves the formation of the species Mn2 plus in the first step. So I know that MnO2 in the first step changes into Mn2 plus. It gains electrons. That means this must be the higher potential because it's gaining electrons, right? So I'm trying to make the first step. So what is happening to the reactant? If this is gaining electrons, the reactant must be losing electrons. So I'm going to look for an equation where H2O2 is losing electrons. So it should be going in the backward direction. So, and I can't find any equation. 1 second. This one. Okay, I'm going to look for this equation. It loses electrons, right? And to lose electrons, it must have the lower potential, right? So that also works. It's got 0.68 volts. So H2O2 turns into O2 plus 2H plus 1. So I have this reaction, H2O2. ये मिलके उसको उसी direction में लिखते हैं. Okay, it's O2 plus 2H plus 1. Plus, I think it was 2 electrons in equilibrium with H2O2, and the E naught was, and the E naught was 0.68 volts. Anyway, so that's this reaction. So what I've done is I've figured out the first step. I figured out the first step because in the first step, this was my reactant. And I had MnO2, and they told us that the MnO2, the first mechanism step involves, in the first step, the MnO2 turns into Mn2 plus. So I found an equation where MnO2 is turning into Mn2 plus, and I figured out that it must be the higher potential. And vice versa, the other one would be H2O2 losing electrons. Okay, is that part clear?
Yes, sir.
So we'll लिख देते हैं. What's the equation? It's going to be H2O2, like I add up the reactants, plus MnO2 plus 4H plus 1, and the products are going to be O2 plus what's the other product? 2H plus 1 plus 2. What's the 2H? O2 plus 2H plus 1 plus 2H2O plus there is Mn2 plus as well. I said there is Mn2 plus as well. Okay, is that clear? Now, let me get rid of this. I said now the second step would be kind of easy. We did the first part, right? I mean, I don't have to do the math for the second step. Remember, the overall equation is the sum of one of the equations or the sum of the two equations, right? So this is equation number 1 plus equation number 2 that gives you the overall equation. Is that clear? So we can either do working and do the whole process, or we can simply, what we can do is, okay, this equation must add up with some other equation, which is my step number 2. And the two equations must add up to give you this. So we just start canceling things out. Like I have MnO2 over here, right? So this other equation should have minus MnO2 because if I add up the left-hand side, there should be no MnO2 on the left-hand side, right? There's H2O2, there's only one of them. So in the other one, there's probably going to be another H2O2. I mean, that's how you're going to get. That's how you're going to get two H2O2s. I said there's 4H plus 1 on this side, so there should be minus 4H plus 1. Okay, so the left side, if you add them up, it gives you 2H2O2. As a right side, this equation must add up with some other equation to give you this product side. So you got 2H2O, I got 2H2O over here. I've got O2 as well. So that's also here. So all I need to do is I need to cancel out this Mn2 plus. So I'm going to put minus Mn2 plus over here. And I also need to cancel out this H plus 1 as well. ठीक है, that needs to be cancelled out. So, and we're now going to rearrange this. So if I rearrange this, it's going to be H2O2 plus Mn2 plus, and my product side would be MnO2 plus how many H plus 1? 2 H plus 1s, right? So that is what my reaction is going.
H plus 1 यहाँ पे H2O लिखेंगे second equation में. H plus 1 cancel out नहीं हो जाएगा?
The second one, it's not cancelling out. I'm just rearranging this. Minus 4H plus 1, take it to the other side. It's going to become plus 4H plus 1. So it's not going to get cancelled. The second one, I'm not. What I'm trying to do in the second one is, I'm not trying to do any working like I did for the first one. Once I have the first equation, I know that the two steps will add up to give me this overall equation. So I'm just trying to, if this is one of the equations, then this thing will get added up with something to give me two H2O2s, right? So I'm just trying to figure out, okay, if I need two H2O2s on the left side, so I already have one H2O2, so the other equation will be bringing in the other H2O2. I've got MnO2 that needs to be cancelled out, so the other equation would have minus MnO2. I've got 4H plus 1. This other one is going to be minus 4H plus 1. Or yahan pe I've got O2, so I have O2, so I'll keep that. I've got 2H2O, so I'll keep that as well. I'm going to cancel all the other things. 2H plus 1, I'm going to put minus 2H plus 1. I've got Mn2 plus, I'm going to put minus Mn2 plus. So this is going to be my other half equation. I'm not sure because I just used a shortcut for this. Iska check kar lo if it is the correct one. But did anyone check? One second.
सर ठीक है.
कौन सा था question?
Question 9 part है.
हाँ ठीक है, we're getting the same thing. ठीक है, you just have to figure out the first equation. As a first equation, we didn't simplify one thing, which was when we wrote the first equation, this 4H plus 1 and this 2H plus 1 over here will get simplified. ठीक है. जो और कोई question है?
किस तरह से?
नहीं वो जैसा math की equation होती है, you've got 4H plus 1 on this side, you've got 2H plus 1 on this side, right? तो
Okay sir.
2H plus 1.
तो third electrode potential क्या होगा?
Okay, third वाला?
जी सर, वो question में 3 electrode potentials दी हुई है.
नहीं उससे मांगा तो नहीं state and use relevant electrode potential to construct two equations to show how MnO2 can, we did use the first one, ठीक है. मैं वैसे ही देख रहा हूँ कि without even solving the rest, क्योंकि मैंने तो skip किया, मैंने तो total calculation second equation किया, I just skipped the calculation, ठीक है. So I'm just saying कि how are the marks divided? 3 marks. One of them is H2O2. I just data seen this and this and the third bhi dena tha. So you actually had to do the working. First step of it is the second step. You had to. अच्छा दोनों के अंदर and आ रहा है, so ठीक है, so you had to do the working for this. अच्छा the working for this would be कि यहाँ पे what is happening to H2O2? H2O2 is losing electrons, right? To form all of this. And you can tell the E0 cell. Okay, it's 1.23 minus 0.68. That's step number 1. Okay, which is this one. So what's going to be the second step? The second step, the catalyst has to be reformed. So in the second step, this equation needs to go back. So it must be the lower potential, right? The Mn2 plus gets converted back into MnO2. Is that clear? It gets converted back to MnO2. So the potential for that is the V potential. It's the same one, 1.23 volts. But if this is losing electrons, then the H2O2 equation must be the higher potential, right? But this is 1.23 volts. Okay, but this is the one that's losing electrons. Second step, it's losing electrons. It's coming back. Who loses electrons? The one that is the lower potential. So this third equation must be the higher potential. And this third equation involves H2O2. So look for an equation of H2O2 where it's the higher potential. So it should be on the left side. So is there H2O2 somewhere? On the, yeah, there's this one, 1.77 volts. So it is the higher potential. Okay, so that would be your H2O2 equation. Is that clear?
जी सर. और सर एक आखिरी चीज कि हमारे कोर्स में वो ये अमीनो एसिड्स और उसकी प्रोटीन्स की डिटेल तो नहीं है ना?
नहीं, बस वो जो एक नहीं वो जो एक क्वेश्चन किया था ना, ये एंजाइम वाला भी पता नहीं है, नहीं है मेरे ख्याल से. मतलब वो एक लॉक एंड की मॉडल होता है.
सर वो है, वो नहीं है ना?
हाँ, ये वैसे तो इसमें कुछ भी नहीं है. जो प्रोटीन का स्ट्रक्चर है ना, प्राइमरी सेकेंडरी टर्शियरी वगैरह, वो तो बिल्कुल भी नहीं है. डीएनए एक्सेट्रा वो
और
भी
वो
है.
बॉन्डिंग भी नहीं है ना, जो प्राइमरी से स्ट्रक्चर में कौन सी बॉन्डिंग
नहीं,
और सेकेंडरी,
वो सब नहीं है. सिर्फ वो पेप्टाइड, जैसा वो लेवल्स में नहीं होता था पेप्टाइड बॉन्ड बना दो, दैट्स सिर्फ वहीं तक है.
ओके सर, ठीक
तो
है.
ये मेरे ख्याल से ये डेफिनेटली अब नहीं है. लेकिन वो एक से देख लेते हैं कि ना, मुझे पता है इट्स नॉट देयर. Just 1 second. हाँ, ये एक चीज याद कर लेना कि ये बीच में एक पॉइंट नोट कर लेना, इसके ऊपर कोई क्वेश्चन नहीं है. ठीक है. हाफ लाइफ, ये दिस इज समथिंग जो मेरे ख्याल से हमने मिस भी किया. इसके ऊपर देयर इज नो क्वेश्चन सो फार इन एनी, इवन आई थिंक बुक में भी मेंशन नहीं है. बट जस्ट रिमेंबर कि इन द न्यू सिलेबस इफ यू मेजर द हाफ लाइफ, जो भी सेकंड्स आ रहे हैं, ठीक है, इफ यू आर एबल टू मेजर द हाफ लाइफ, then your rate constant is 0.693 divided by the half life. ठीक है. But simple है कि if you know what the half life is, तो
ओके सर.
हाँ, लेकिन इसके ऊपर there is absolutely no question so far. ठीक है, it's not mentioned anywhere. लेकिन इसको कहीं नोट कर लेना. ठीक है. अच्छा, वो क्या था, मैंने वो एंजाइम का पता करना था कि नहीं, एंजाइम कुछ भी सर्च नहीं हो रहा.
चलो ठीक है.
मतलब एंजाइम वर्ड एटलीस्ट वर्ड सिलेबस में नहीं है.
ठीक है सर. थैंक यू सर.
चलिए ठीक है. चलिए, ओके एवरीवन.
हाफिज़ सर.
ठीक है, अल्लाह हाफिज़.
Officer.